So hello guys, today we are going to discuss Physics Paper 1 2021 SPP. So the first question, which of the following base quantity and its SI units is correct? So base quantity, just a revision here, we have 7 of them. But in your syllabus, the important one is the first 5 one. The first one, length, second, mass, length, mass, time, temperature, and currents. This is the 5 important base quantity you need to know. Length, the SI unit is meter. Mass, the SI unit is kg, kilogram. Time is second. Temperature is Kelvin. Remember, temperature, the SI unit is Kelvin, not degree Celsius, Kelvin. And the current is ampere. Alright, so from here you know mass should be kg, current should be ampere, not milliampere. Time should be second, we don't have this kind of SI unit. And temperature should be K, so the answer is donkey. Next, which graph represents the relationship of y inversely proportional to x? So y inversely proportional to x should be like this. So when it is inversely proportional to x, you get a graph like this. Okay, but when you convert it's to y, and here x-axis is x, it will become like this. So the answer should be boy. This graph represent y directly proportional to x. Okay, this is decreasing linearly. This is increasing linearly. So you need to take note that when y is directly proportional to x, it must start from 0. When it is not starts from 0, it is increasing linearly. Okay, next, okay, diagram 1 shows a velocity time graph for a car moving in a straight line. So this is velocity time graph. So remember, if it is displacement time graph, so the gradients will be velocity, while if it is a velocity time graph, the gradient will be acceleration. Okay, remember our acceleration a equals to final velocity minus initial velocity divided by time. So acceleration, how you get the gradient is y1 minus y2 equals to x1 minus s2, where your y is velocity and your x is time. So remember, our acceleration is the gradient. So what is the type of motion for car at QR? So the gradient here is 0, so the acceleration is 0. When your acceleration is 0, your velocity is constant. Okay, so constant acceleration. Okay, you can see the gradient is constant. Okay, the steepness for these parts and these parts, they are the same. So if this is constant acceleration, this one should be constant deceleration. You can see the velocity is decreasing. This is deceleration. And here, the steepness is the same, but the velocity is increasing. So this is constant acceleration. So constant acceleration should be this one. And the velocity increases. This is also for this one. And the acceleration increases. At here, both the acceleration is a constant. So what you have when the acceleration is constant is should be like this, where this one is v, velocity, and this one is time. So yes. So when your velocity, you can see when you draw a triangle, okay, the steepness is increasing. Alright, so you get a curve shape if your acceleration increasing, so your gradient is increasing. Gradients increasing. Okay. Next, diagram 2 shows a racing cyclist who is thrown forward when he pulls the brake suddenly. Which basic law is involved? So Newton's universal law of gravitation. So this one, law of gravitation is Gmm/r squared. So this is not true. This is incorrect for this uh, diagram. Newton's first law of motion is about inertia. Second law of motion is about F equals to ma. Okay. Third law of motion is about action and reaction force. So remember, third law of motion is about action and reaction force. Okay, action and reaction force. So in every action force, they will have a reaction force which is equal magnitude, but opposite in direction. While Newton's second law of motion states that F force is directly F equals to ma. So the answer should be void inertia. Why? Because the bicycle and the cyclist, it is moving at a speed v. So when the bicycle stops suddenly, the cyclist here will continue to move with speed v, because so this is what we state in Newton's first law. So the answer should be B. The A is basically involves weight. Okay, if in Earth it involves weight. If in the space it's about F equals to Gmm/r squared. So the answer should be B. This one is wrong. Okay. Next, diagram 3 shows two rugby players collide in a rugby match. After the collision, they move together. So which statements are correct? Total momentum is conserved. Okay, so for every collision, the total momentum will always be constant. So this is true. Total kinetic energy is conserved. Okay, we have two types of collision. One is elastic collision. Okay, let me enlarge my word. So elastic collision, and another type of collision is inelastic collision. So elastic collision is happens when collision, okay, for example, object A and B, so it moves in this direction, move in V, and move in A, move in speed V, and B move in speed U. So for elastic collision, after it has collided, after they have collided, they will repel, okay, with another speed. So this is elastic collision. Inelastic collision is that, okay, this is A, this is B. The mass of it is 2n. This is 1n, and then speed v, and then this is speed u. After they collide, they will move in this direction. They will stick together because A has a larger mass, so so it will move in this direction and they are stick together. So they say that after the collision they move together. So in this case, this should be inelastic collision. So this is wrong and this is correct. So elastic collision, total kinetic energy will be conserved in elastic collision, but will not conserve in elastic collision. So since this is inelastic, this should be wrong. So the answer should be IV should be void. Okay, so which tool can be used to measure force? So to measure force, we'll use spring balance. Okay, the answer should be B. So electronic balance we use to measure weight. Lever balance we also use to measure weight. And inertial balance is those experts will use this inertial balance to measure mass in space. Okay, so this force we will use spring balance. Boy is the answer. Diagram 4 shows Abdul Latif bin Ramli bin blah 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 in long jump events. Okay, so which technique that he used to reduce injury? The answer should be donkey, bend the knee when landing. So for this question, you need to understand the concept of impulsive force. Impulsive force. Okay. So impulsive force. Just a revision here. The meaning of impulsive force is you need to memorize the definition of it because this definition they come out quite frequent in your exam. So it's the rate of change of momentum, rate of change of momentum during collision or explosion in a short time interval. Okay, so just a warm reminder here, you have to emphasize on during collision or explosion and in a short time interval. Okay, you cannot just write rate of change of momentum because sometimes the examiner might not accept it. Okay, so you need to memorize this one. Momentum. Okay, sorry. Okay, so you need to remember during collision or explosion in a short time interval. This is the best answer of it. So just a reminder, the formula of this impulsive force is impulsive force mv minus mu over t. Okay, so when you bend the knee, you will reduce the impulsive force by increasing the time of collision. Okay, so when you increase the time of collision, the impulsive force will decrease. The impulsive force acts towards your knee will be decreasing, and you are less likely to get injured. Okay, moving on. Let's look at number 8. Johann Kepler succeeded in formulating 3 laws that describe the moments of planets around the Sun. The square of the period of a planet's orbit is directly proportional to the cube of the orbital radius. So what this means here is t squared directly proportional to r cubed. Okay, so this is Kepler's third law. Remember, Kepler's first law is about the ellipse. It states that it's about the orbital. It states that the planets will move around the Sun where its orbital is an ellipse. Okay. And the second law, Kepler's second law, is about equal area, equal time. When a line that connects from the planets to the Sun, it sweeps out equal area in equal time. Okay. Okay, next. Diagram 9 shows a geostationary satellite is orbiting the Earth. Geostationary satellite. Okay, so you see the word here, geostationary. You see the stationary here. Stationary means it didn't move. So it means that when you see geostationary, it means that, for example, here, the Earth here, the points here is at KL. Okay, so when you are at KL, you look up into the sky, the satellite will always there. Although your Earth is keep rotating, And because our satellite is rotating the same speed, same direction as our Earth, you will always observe from KL that this satellite will always above KL, above your location. So this is what geostationary satellite means. So which statement is correct about the satellite? The orbital period of the satellite is more than 24 hours. This is not true because it will always located above KL. If it is more than 24 hours, then this satellite will become non-geostationary and it will no longer above KL. Next, the orbital period is shorter. Same reason, this is not true. The satellite has direction of motion same as the Earth direction of Earth rotation. This is true. The satellite is above different geographical location at different times. This is not true because this is geostationary. It is always located above a particular location. So the answer you have is C. So question 10, diagram 5 shows a clinical thermometer used to measure a patient's body temperature. What is the physics concept that is applied in the thermometer? Okay, so specific heat capacity, no, because specific heat capacity is about the amount of energy you apply in order to increase the temperature of 1 kg substance, 1 kg, because this here is specific. If it doesn't have this word specific, it's you can neglect this 1 kg. So specific heat capacity, amount of energy you need to increase the temperature of 1 kg substance by 1 degree Celsius. This has nothing to do with your thermometer, so this is no. Thermal equilibrium, yes, because your heat is transferred, the heat from this child is transferred to the thermometer, so this is true until they reach equilibrium. So the temperature of this thermometer equal to temperature of this child, so this is correct. This is correct. This is true. Specific latent heat of fusion. This is wrong. Specific latent heat of vaporization. This is also wrong. So heat of fusion, you see this word fusion, so you have to know it involves solid and liquid. Okay? Solid and liquid. So specific latent heat of fusion is the amount of energy you want to change solid to liquid or liquid to solid, liquid to solid or solid to liquid. So fusion involves these two types of state. So liquid to solid is freezing, and solid to liquid is melting. Okay, so specific latent heat of vaporization. So you can, when you see this vapor, it involves liquid to gas or vice versa, liquid to gas or gas to liquid. Okay, so liquid to gas, boiling, gas to liquid, condensation. So you want to change the state of a matter, you need this energy to convert gas to liquid, or you need this heat of fusion to convert liquid to solid. So just to for you to have a clearer image, so this is your temperature, this is your time, and okay, this is the graph. So at here, at the highest temperature here, this is gas, and this is gas and liquid. So this is at here is liquid, and at here is solid. Okay, so when you see here, the constant temperature here is where you involves the heat of fusion or heat of vaporization. So gas and liquid here is heat of fusion, and gas, liquid and solid here is vaporization. Okay, so whenever you saw this latent heat of fusion, latent heat of vaporization, it's mostly involves the change of state of matter. So when you see a question involves change of state of matter, so it's most probably involves this latent heat of fusion or vaporization. Okay,